Terminating and repeating decimals, U2.C4.L1. Take it away, Mrs. Benoit.
Hi, welcome to Unit 2. We're going to be doing all videos for this unit, so we are officially flipping the classroom. This is the third video that we've done, okay, and it's on terminating and repeating decimals. Your learning target for this is that you will be able to say, I can write fractions as terminating or repeating decimals and write decimals as fractions. At the bottom here, I have the target that you're going to try to hit at the end. There's 3 problems here. Again, don't worry about this now. We're just showing this to you, and then you will see these again at the end of the lesson. Any fraction can be written as a decimal, and the key to it is dividing the numerator of that fraction by the denominator. So let's take 4/5 for example. 4 is the numerator, it's in the top, and 5 is the denominator in the bottom. To set up the division, you'll actually have to do long division. The numerator goes on the inside, and the denominator is on the outside. Now when you look at this, you say, how many 5s can go into 4? They can't. There's not enough there. So that's where the decimal comes into place. And you were doing this last year, I believe. So you add the decimal point after the 4, and you put a decimal point on top of your division bar. And then add a couple zeros. 2 or 3 are usually good. Now you're looking at how many times 5 can go into 40. And if you know your facts, you know that there's 8 5s in 40. 8 times 5 is 40. Subtract, and there's nothing left. So the decimal equivalent of 4/5 would be decimal point 8, or we read that as 8/10. It's going to be very important in this lesson that you're reading the decimals as decimals to help you convert from decimals to fractions and the other way. We have 2 types of decimals that you're going to come across: terminating decimals and repeating decimals. Terminating decimals have an end. They stop. So just like on the previous slide with our 4/5, when we divided that to find the decimal equivalent, it was 8/10. There was an end, that 8 after the decimal point. Repeating decimals, on the other hand, are the opposite of that. They repeat. They go on and on and on. And to mark that we have a repeating decimal, we use something called bar notation, where we put a bar above the decimal that repeats. So let's look at 2/3 here. If we use what we talked about on the last slide and divide our numerator by our denominator, we'll have 2 on the inside, 3 on the outside. Add that decimal point because 3 can't go into 2. How many 3's go into 20? 6. 6 times 3 is 18. 20 minus 18, you're left with a 2. You have 20 again. So the 6 is going to keep repeating. Instead of having to write a bunch of 6's after that decimal point, you would say 2/3 is equal to decimal point 6 repeating, or 6/10 repeating. And here's that bar notation right there. You draw the bar over the part that repeats. Okay? So let's change some fractions to decimals. And after we've changed them, we're going to determine, are they terminating decimals or repeating decimals? My first example is 3/25. Instead of doing the division here, sometimes there's another way that you can do your conversion. Actually, am I going to do that? Yeah, I'm going to do that on this one. Okay. If your denominator is a factor of 100, you can change your fraction out of 100, and then the conversion will be really quick. So we're going to create a equivalent fraction, and we're going to change our fraction to be out of 100. So how many 25s go into 100? 4. You think of 4 quarters in a dollar. Okay, so you have to multiply 25 by 4 to get to that 100. Creating equivalent fractions means what you do on the bottom, you have to do on the top. So what I did to the denominator, I'll do to the numerator. 3 times 4 is 12. So this is 12 hundredths. That's how you read that fraction, 12 hundredths. How do you write 12 hundredths as a decimal? You put your decimal point, and if you know your place value, tenths is the first place, hundredths is the second, so it would be decimal point 12, 12 hundredths. Does this decimal end, or does it repeat? I didn't have to do a bar. I'm not writing the same numbers over and over, so I would call this a terminating decimal. My next example is actually a mixed number, 4 1/3. What do you do when you have a mixed number with that whole part? For right now, you just kind of leave it off to the side. Don't worry about it, okay? Don't forget about it at the end. We'll come back to it, but you don't need to worry about that whole part. We'll add it on at the end. So we're looking at 1/3. 3 doesn't go into 100 like 25 did, so I'm not going to be able to do a quick fix on this one. I'm going to have to do the division. So I'll set up my long division, putting the denominator on the outside and the numerator on the inside. How many 3's go into 10? 3. 3 times 3 is 9. You're going to subtract. 10 minus 9 is 1. And we have 10 again. How many 3's go into 10? 3. So you see that the 3 is going to be repeating. So you have decimal point 3, or 3/10 repeating. That takes care of the fraction part. Our whole part from the mixed number, we now are going to add to that. So 4 plus 3/10 is 4 3/10. Repeating. Don't forget that bar notation on the 3. And I just said, I gave it away, is it terminating or repeating? It's repeating. Even though you have the whole part that isn't part of the repeating, the bar only goes over the 3. We can go the other way from decimals to fractions, and this is where it's very important that you are saying the decimals correctly to help you set it up in fraction notation. So this decimal is 2 places after the decimal point. It ends in the hundredths place, so you would read this as 46 hundredths. So you write it, 46 over 100, 46 hundredths. Okay, this is fraction form, but it's not in lowest terms. So we're going to think of a factor that we can divide out of both. I look at this and think, well, they're both even, so I'm going to start with 2. So I'm going to divide 2 out of the numerator, and what I do to the numerator, I have to do to the denominator. So it has to work in both. 46 divided by 2 is 23, and 1/2 of 100 is 50. 23 is odd, 50 is even, so we're not going to be able to do 2 anymore, and 23 is actually prime. So this is where we stop. 23 50ths would be the fraction equivalent of 46 hundredths as a decimal. My second example has 3 places after the decimal, so you really need to know your place value here. Tens, tenths, hundredths, thousands. So you would read this as 125 thousandths. You put it over 1,000. Okay, this time they're not both even, but they are both divisible by 5 because it ends in 5 or 0. So I'm going to do 125 divided by 5 and 1,000 divided by 5. 125 divided by 5 would be 225. 25. And then 1,000 divided by 5 would be 200. I have a 5 and a 0 again, so I can take another 5 out. So I didn't find the greatest factor to divide out at first, but that's okay. You can do it in small parts like this and keep going. So 25 divided by 5 is 5, and 200 divided by 5 is 40. 5 and 40 still have a 5 in common, so we'll divide by one more 5. 5 divided by 5 is 1. Come over here. And 40 divided by 5 is 8. So 1/8 is the fraction equivalent of 125 thousandths. Okay, now we're going to see if you can hit the target. I have a couple problems for you to practice writing as a decimal and one as a fraction. I want you to change 5/9 and 3/10 to a decimal and then tell us, are they terminating or repeating? And then I want you to take negative 32 hundredths and write it as a fraction, and I'm going to add as a fraction in simplest form. If you have any questions, you can ask me or Mr. Romanovich or rewatch the video.